Hello, in this lecture we will answer on two questions. In the first question, we will find out the side length of square ABCD. In the second question, we will find out the length of line segment X. Okay, so we'll start with the first question. In the drawing, we have square ABCD. We know that the radius of this circle is equal to 2 units. We also know that line segment DE, the short line segment DE is equal to 1 unit in its length. And we want to find out the side length of square ABCD. So first of all, we will define the side length of square ABCD as X. So actually here, AB will be equal to X, of course, according to our definition. AD will be also equal to X. This equals to X. And CB will be also equal to X according to our definition. Okay. And we have the first rule here that a tangent to a circle is perpendicular to the radius drawn to its point of tendency. We know that the radius of this circle is equal to 2 units, so we'll define the radius of this circle as R, and R equals to 2 units. We will define the point of tendency of tangent AD with this circle as M. We define the center of this circle as O. So here the radius MO, it is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AD with this circle. And whenever we have a radius that is drawn to the point of tendency, then according to rule number 1 that I mentioned, the tangent AD will be perpendicular to the radius MO. So AD is perpendicular to MO. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We define the point of tendency of tangent AB with this circle as L. We join points O and L together by a straight line. ON is the radius of this circle. That is to say, it is equal to R, that is equal to 2 units according to what is given us in the question. So YON is the radius of this circle because of the fact that line segment ON starts from point O, that is the center of this circle, and ends at point L, that is the point of the circle itself. This is exactly the definition of a radius. That is to say, OL is the radius of this circle that is equal to R, and R equals to 2 units. So we have here the radius OL that is drawn to the point of tendency, that is to say, it is drawn to point L, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius LO. So if AB is perpendicular to LO, it means that this angle equals to 90 degrees and this angle will be also equal to 90 degrees. Okay? In addition, we also know that all the angles inside the square are right angles, that is to say angle BAD will be equal to 90 degrees. So actually in quadrilateral MOAN we have 1, 2, 3 right angles. Okay? I write it down. In quadrilateral MOAN we have 3 right angles. The sum of 3 right angles is 90 degrees times 3 is 230 degrees. Plus the size of the fourth angle, that is actually angle MOL, this angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we'll subtract 270 degrees from this equation, and we get that the missing angle, angle MON, is equal to 360 degrees, almost 270 degrees, it is 90 degrees. So if I know that angle MON equals to 90 degrees, it is a right angle. So actually inside quadrilateral MOAN, we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle. So we relate to quadrilateral MOAN as a rectangle. Okay. But we also know that the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle MOAN are equal to each other. It means that MO equals to AN. MO equals to AN, according to the rule that the opposite sides of rectangle are equal to each other. But we already found out that MO equals to 2 units. It is the radius of the circle. So we can write here that MO equals to 2. And from this equation 2 equals to MO equals to AN, we derive that AN is also equals to 2 units. AN is also equals to 2 units. So we can write here that AN equals to 2 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, in rectangle MOAN, MA must be equal to ON. Again, MA must be equal to ON. But ON equals to 2 units. It is the radius of the circle, so you can write here that ON equals to 2. And from this equation, MA equals to ON equals to 2, we will derive that MA is also equals to 2 units. MA equals to 2 units. You can write here that MA equals to 2 units. So actually we found out that all the sides of quadrilateral MOAN are equal to each other, therefore quadrilateral MOAN is not a rectangle but a square. So you can write down that quadrilateral MOAN is a square. Okay. In the next step, I will present to you a new rule. That, it is not new rule, but it is a rule that I have already mentioned in the past, and it will be rule number 2. According to rule number 2, the lengths of two tangents from a common extra point to a circle are equal. I'll repeat again. The lengths of two tangents from a common extra point to a circle are equal. So we'll focus on the common extra point, point E. From the common extra point, point E, we have two tangents to this circle. The first tangent is tangent EM. And here we define the point of tangency of line segment EB with this circle as Z. And the second tangent from point E to this circle is EZ. And according to rule number 2, the lengths of those two tangents must be equal to each other. That is to say, EM equals to EZ according to rule number 2. Okay. What is the length of tangent EM? The length of tangent EM, from the drawing it is very easy to see that the length of tangent EM is equal to DA minus DE minus MA. I repeat again. The length of tangent EM equals to DA minus DE minus MA. Okay, so the length of tangent EM is equal to DA. According to our definition, DA equals to X, so we substitute DA by X minus DE. DE equals to 1 unit according to what is given us in the question, so we substitute DE by 1 minus MA. MA equals to 2 units according to what we have already found out. So in conclusion, we found out that EM equals to X minus 1 minus 2. X minus 1 minus 2 is X minus 3. So we write down that EM equals to X minus 3 units. So we write here that EM equals to X minus 3 units. But we have already found out that according to rule number 2, EM equals to EZ. We just right now found, and we also just right now found out that EM is also equals to X minus 3. So we can write here that EM equals to X minus 3. And from this equation, X minus 3 equals to EM equals to EZ. We will derive that EZ is also equals to X minus 3. EZ equals to X minus 3. EZ equals to X minus 3. In the next step, we'll focus on the common external point, point B. this common external point B. From the common external point B, we have two tangents to this circle. The first tangent is tangent BL. And the second tangent is tangent BZ. And according to rule number 2, we know that the lengths of those two tangents must be equal to each other. That is to say, BL equals to BZ according to rule number 2. What is the length of tangent BL? The length of tangent BL, from the drawing it is very easy to see that the length of tangent BL, here, BL equals to BA minus LA. Again, BA minus LA equals to BL. BA minus LA. So the tangent BL equals to, in its length, to BA. BA equals to X according to our definition. Minus LA. LA equals to 2 units according to what we have already found out. So, actually, in conclusion, we found out that BL equals to X minus 2. Yes, we can write here that BL equals to X minus 2. But according to rule number 2, BL equals to BZ. For one side, but for the other side, we just right now found out that BL it is also equals to X minus 2. So we can write down here that BL equals to X minus 2. And from this equation, X minus 2 equals to BL equals to Z. X minus 2 equals to BL equals to BZ. We will derive that BZ is also equals to X minus 2. BZ equals to X minus 2. Here, BZ equals to X minus 2. And what is the length of line segment EA? The length of line segment EA from a drawing, it is very easy to see that the length of line segment EA is equal to DA minus DE. Again, DA minus DE equals to EA. DA minus DE. So repeat again. EA equals to DA minus DE. So here EA equals to DA equals to X according to our definition, minus DE equals to 1 unit according to what is given us the question. So in conclusion, we found out that the length of line segment EA equals to x minus 1. So in the next step we will implement the Pythagoras theorem on the right triangle, triangle EAB. So I will copy the right triangle EAB in this new page and we will implement the Pythagoras theorem on this triangle, triangle EAB, this right triangle, triangle EAB. Okay? We just right now found out that EA equals to x minus 1. AB equals to x according to our definition. And what is the length of the hypotenuse EB? The hypotenuse EB equals to its length to x minus 3 plus x minus 2. I'll repeat again. The hypotenuse EB, it is B. The hypotenuse EB equals in its length to x minus 3 plus x minus 2. X plus x is 2x. Minus 3 plus minus 2 is minus 5. So in conclusion, I found out that the hypotenuse EB equals to 2x minus 5. In the next step, we will implement the Pythagoras theorem on this right triangle, triangle EAB. So here EAB by PT is a variation for Pythagoras theorem. We get that according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is EB, therefore the square of the hypotenuse is EB squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to EA squared plus AB squared. So according to the Pythagoras theorem, we found out that EB squared equals to EA squared plus AB squared. So EB equals to 2x minus 5, therefore EB squared is 2x minus 5 squared. That is equal to EA squared. EA equals to x minus 1, so EA squared is x minus 1 squared. Plus AB equals to x, so AB squared will be equal to x squared. Okay, so here we will open the brackets on both sides of this equation, equation number 1. According to the algebraic identity that states that A minus B squared equals to A squared plus B squared minus 2 times AB. So here 2x minus 5 squared will be equal to 2x squared, that is 4x squared, plus 5 squared, that is 25, minus 2 times 2x is minus 4x, and minus 4x times 5 is minus 20x. And it is equal to x minus 1 squared, x minus 1 squared, it is equal to x squared, plus 1 squared, that is 1, minus 2x, plus x squared. So here 4x squared minus 20x plus 25 equals to, here x squared plus x squared is 2x squared minus 2x plus 1. So according to equation number 1, here we subtract 2x squared from this equation number 1, and we get that 4x squared minus 2x squared is 2x squared. We'll also add 2x to this equation number 1. 2x minus 2x is 0. 20 minus 20x plus 2x is minus 18x. We will subtract 1 from this equation number 1. 1 minus 1 is 0, so, and 25 minus 1 is 24. In conclusion, we found out that according to equation number 1, 2x squared minus 18x plus 24 equals to 0. Here we divide this equation number 1 by 2. X squared over 2 is x squared. Minus 18x over 2 is minus 9x. 24 over 2 is 12. 0 over 2 is 0. So actually we got here the quadratic equation x squared minus 9x plus 12 equals to 0. The coefficient a in this quadratic equation is 1. The coefficient b is minus 9. And the coefficient c is 12. And the general formula for solving out the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. So in order to find out the value of x in our specific quadratic equation, we'll put the data inside this formula, and we'll find out the value of the values of x. So here we get that x equals to minus b. b equals to minus 9, so minus b is minus 9, that is plus 9. Plus minus square root of b squared. B equals to minus 9, so b squared is minus 9 squared, that is 81. Minus 4 times a is 1, times c is 12. Over 2a. a is 1, so 2 times 1 is 2. So here x equals to 9 plus minus square root of 81 minus 4 times 12 is minus 48 over 2. So here actually found out that x equals to 9 plus minus 81 minus 48 is 33, so inside the root we left only with 33 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to 9 minus square root of 33 over 2. 9 minus square root of 33 over 2 is 1.62. So we found out that x equals to 1.62. Okay? X equals to, according to the first solution, x equals to 1.62. So here x that is actually equals to AB, it is equal to 1.62. But from the drawing, it is very obvious that x is greater than AL. X is greater than AL, and AL equals to 2 units. That is to say, x is greater than AL, that is equal to 2 units. It means that x must be greater than 2 units. X must be greater than 2 units for the drawing. We can see it obviously, that x must be greater than 2 units, while x that is equal to 1.62, it is less than 2 units. So, therefore, we will cancel this solution, and we left only with the second solution for x. The second solution for x is x equals to 9 plus square root of 33 over 2 units, or in terms of numbers, it is equal to 7.37 units. I repeat on the question, on the answer, x equals to x that is one side of square ABCD equals to either 9 plus square root of 33 over 2 units, or in terms of numbers, it is equal to 7.37 units. Here, x, that is one side of square ABCD, it is equal to either 9 plus square root of 33 over 2 units, or in terms of numbers, it is equal to 7.37 units. So we finish with the first question. In the next step, I will present to you the second question, and we will solve the second question in 2 different methods. Okay. Here, in the drawing, we have triangle ABC. We know that 9 segment BD equals to 2 units, side AB equals to A units, side AC equals to 2A units, angle BAD equals to 60 degrees, angle DAC is also equals to 60 degrees, and we want to find out the length of side AD that is equal to x. Okay, so first of all, I will present to you a rule that is actually the angle bisector theorem. According to the angle bisector theorem, so first of all, the angle bisector theorem is true in any triangle. So if we have a triangle ABC, that could be any triangle. This is triangle ABC. And we know that AD is the angle bisector. Why AD is the angle bisector? Because of the fact that it divides angle BAD into two halves. Each half equals to theta. So AD is the angle bisector. So, according to angle bisector theorem, we get that AB over AC equals to BD over DC. So whenever we have in a triangle an angle bisector, that the following equation is true, that AB over AC equals to BD over DC. And we can use the angle bisector theorem only and only if we have angle bisector in the triangle. So here, because of the fact that in triangle ABC we have AD, that is angle bisector, we can use the angle bisector theorem, we can implement the angle bisector theorem in triangle ABC. Why line segment AD is angle bisector? Because of the fact that it divides angle BAC to two halves. Each half equals to 60 degrees. So angle BAC equals to 120 degrees, and it divides angle BAC to two halves, each half equals to 60 degrees. That is the reason that we can implement the angle bisector theorem in triangle BAC. Okay, so we'll implement the angle bisector theorem in triangle ABC. According to angle bisector theorem, so write it that AD is the angle bisector, of course. AD is the angle bisector. So according to angle bisector theorem, we get that AB over AC equals to BD over DC. I repeat again, because of the fact that in our triangle ABC we have the angle bisector AD, we can implement on our triangle ABC the angle bisector theorem, and according to angle bisector theorem we get that AB over AC equals to BD over DC. Okay. So AB equals to A units according to what is given us in the question, so we'll substitute AB by A. AC equals to 2A according to what has been given to us. So we substitute AC by 2A, and it is equal to BD equals to 2 units according to what has been given to us in the question. So we'll substitute BD by 2, and DC is the missing line segment, so we'll leave it as it is. So actually we found out that according to equation number 2, 2 over A over 2A equals to 2 over DC. A over A is 1, so A will get cancelled. And in this side of the equation number 1, we left only with 1 half. According to equation number 1, 1 half equals to 2 over DC. Here we cross multiply this equation, equation number 1, and we get that 2 times 2 equals to DC. That is to say, this equals to 2 times 2, and 2 times 2 is 4. So found out that this equals to 4 units. In the next step, we will do a construction. We will extend side CA of triangle ABC by a straight line. And then from point B, we will raise perpendicular to the extended CA. Okay? Actually, this angle equals to 90 degrees according to our construction. And we will define the touching point of the extended line segment CA and the perpendicular from point B as E. So repeat again that angle AEB, this angle equals to 90 degrees according to our construction. Here, line segment CA is one side of triangle ABC. So CA, line segment CA is a side of a triangle. It is absolutely a straight line. Okay? And then after we extended the straight line CA by straight line, we got line segment EC. When you extend the straight line by straight line, the result must be a straight line. So we extended the straight line CA by straight line, and the result is EC. So EC must be a straight line, because when you extend the straight line by straight line, the result must be a straight line. So EC is a straight line. And we have the rule that the sum of the angles on the upper side of a straight line is equal to the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the lower side of the straight line EC at point A, then the sum of the angles here must be 180 degrees. So here at the lower side of the straight line EC at point A, which angles we have here? We have here 60 degrees. One angle is 60 degrees. The other angle is also 60 degrees. And we also have here angle EAB. In total, the sum of those three angles must be equal to 120 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay? So here at the lower side, in the lower side of the straight line EC at point A, the sum of the angles must be equal to 180 degrees, that is to say 60 degrees plus 60 degrees plus angle EAB. In total, they must be equal to 180 degrees. 60 degrees plus 60 degrees is 120 degrees, plus angle EAB, they must be equal to 180 degrees. If we subtract 120 degrees from this equation, and we get that angle EAB, the missing angle EAB, equals to 180 degrees minus 120 degrees, it is 60 degrees. Okay, so now that this angle EAB equals to 60 degrees, so in the next step we will focus on the right plane triangle EAB. The right plane triangle EAB. We know that cosine 60 degrees equals to EA over BA. I'll repeat again. The right plane triangle EAB, cosine 60 degrees equals to EA over BA. So cosine 60 degrees equals to EA over BA. BA equals to A according to what is given as the question. So we substitute BA by A. So in conclusion, we found out that cosine 60 degrees equals to EA over A. Cosine 60 degrees equals to 1 up, so we substitute cosine 60 degrees to 1 up. 1 up equals to EA over A. Here we cross multiply this equation, and I will multiply this equation by A, and we will get that according to this equation, we get that EA equals to A over 2. EA equals to A over 2. Here we can write down that EA equals to A over 2. We will continue to focus on the great right triangle EAB. On the great right triangle EAB, sinus 60 degrees equals to EB over BA. I'll repeat again. On the right given triangle EAB, sinus 60 degrees equals to EB over BA. So sinus 60 degrees equals to EB over BA, but BA equals to A according to what is given as the question, so we'll substitute BA by A. And we found out that sinus 60 degrees equals to EB over A. Sinus 60 degrees equals to square root of 3 over 2, so we'll substitute sinus 60 degrees by square root of 3 over 2, and it is equal to EB over A. Here we'll multiply this equation by A, and we'll get that EB equals to A times square root of 3 over 2 units. So we can write down in the drawing that EB equals to A times square root of 3 over 2 units. In the next step, we will implement the Pythagoras theorem in the right big triangle, BEC. Okay, so I'll copy the right big triangle BEC in the new page and we will implement the Pythagoras theorem on this right triangle BEC. What is the length of side EC or CE? The length of side CE, it is equal to 2A plus A over 2. 2A plus A over 2 is 2.5A, or we can present it as 5 over 2A. So EC equals to 5 over 2 times A. And we already found out that EB equals to square root of 3 over 2 times A. And the hypotenuse BC equals to 2 plus 4, that is 6. So this is the right triangle EBC that I copied from the original drawing. We will implement the Pythagoras theorem on this right triangle EBC. So here, by PT is the relation for Pythagoras theorem. This will be equation number 1. And equation number 2, of course. Actually, according to equation number 2, we get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BC, so the square of the hypotenuse is BC squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to BE squared plus EC squared. So according to equation number 2, we get that here with BC squared, BC equals to 6. Therefore BC squared is 6 squared, that is 36. And it is equal to BE squared. BE equals to square root of 3 over 2 times A, therefore BE squared will be equal to square root of 3 over 2 times A squared plus EC squared. EC equals to 5 over 2 times A. Therefore EC squared will be equal to 5 over 2 times A squared. So we will open the brackets on this side of equation number 2, and we get that according to equation number 2, (36) equals to square root of 3 over 2 times A squared. Square root of 3 squared is 3, over 2 squared is 4, times a squared plus 5 halves a squared. 5 squared is 25 over 2 squared is 4 times a squared. So here we have 3 quarters plus 25 quarters is 28 quarters times a squared, of course. That is equal to 36 according to equation number 2. 28 over 4 is 7. So 7a squared equals to 36 according to equation number 2. Here we will divide this equation number 2 by 7, and we'll get that according to equation number 2, a squared equals to 36 over 7. Here we'll take a look out of this equation number 2. And we get that according to equation number 2, a equals to the square root of 36 is 6 over square root of 7 units. A equals to 6 over square root of 7 units. We found out the value of a. So in the next step I will present to you a new rule that is actually rule number 3. According to rule number 3, we get that if we have triangle ABC that could be any triangle, this is triangle ABC, and we also have the angle bisector AD. AD is angle bisector because of the fact that it divides angle BAC into 2 halves, each half equals to theta. So I write it down here that AD is angle bisector. So actually according to rule number 3, we get here that AD squared equals to AB times AC minus BD times DC. I'll repeat again, if we have triangle ABC that could be any triangle, and in triangle ABC we have the angle bisector AD, then according to rule number 3, the following equation is true that AD squared equals to AB times AC minus BD times DC. Okay, it is true in any triangle that has the angle bisector. So we already found out that in our specific triangle ABC, we have the angle bisector AD, therefore we can implement rule number 3 in our triangle ABC. So we do it now. We have triangle ABC. So I'll copy the triangle BAC in a new page, and we will implement rule number 3 in our triangle ABC. We can implement rule number 3 in our triangle because of the fact that in our triangle ABC we have the angle bisector AD. Okay. I repeat again that here AD is the angle bisector, AD equals to x according to what's given in the question. So I write here that AD is the angle bisector. Because of the fact that we have here the angle bisector AD, we can implement rule number 3 in triangle ABC. And according to rule number 3, this will be equation number 3. AD squared equals to AB times AC minus BD times DC. Okay, so this is actually the implementation of angle bisector of rule number 3 in our triangle ABC. AD square equals to AB times AC minus BD times DC. So here AD equals to x, so AD square will be equal to x square. That is equal to AB is A. AC is 2A minus BD is 2 times DC is 4. So here, according to equation number 3, we'll get that x squared equals to A times 2A is 2A squared minus 2 times 4 is minus 8. So we found out that according to equation number 3, x squared equals to 2A squared minus 8. So x squared according to equation number 3 equals to 2 times A squared. We already found out that A squared equals to 36 over 7, so we'll substitute A squared in this equation number 3 by 36 over 7 minus 8. Okay, 2 times 36 is 72. So I write it down. Found out that according to equation number 3, x squared equals to 72 over 7 minus 8. Okay, so here we will multiply minus 8 by 7 and then we will divide it by 7 in order to have a common factor with this expression. Minus 8 times 7 is minus 56 divided by 7. So x equals to 72 minus 56 is 16. So actually, in conclusion, we found out that x squared equals to 16 over 7. We take a root out of this equation number 3, and we get that x, the variable that we are looking for in this question, it is equal to square root of 16, that is 4, over square root of 7. So x equals to 4 over square root of 7 units. Or in terms of numbers, it is equal to 1.51 units. 1.51 units. So here x equals to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. We finished with the first method. In the next step, I will present to you how to find out the length of line segment AD that is equal to x according to the second method. In the second method, we define angle ADB as theta. So So if angle ADB equals to theta, and BC is one side of triangle ABC, it is a straight line, then angle A, we know that the sum of the angles on one side of the straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BC at point D, then the sum of the angles must be equal to 180 degrees. So if angle ADB equals to theta, then angle ADC must be equal to 180 degrees minus theta. Why? Because theta plus 180 degrees minus theta equals to 180 degrees. Okay. So in the next step, I will present to you the law of sines. They were already mentioned in the past. So here, the law of sines is true in any triangle. So if you have triangle ABC, that could be any triangle. This is triangle ABC. And we know that side BC of triangle ABC equals to A units in its length, side AC equals to B units in its length, and side AB equals to C units in its length. Then according to the law of sines, we'll get that A over sinus A equals to B over sinus B. That is equal to C over sinus C. So here capital A is the size of angle BAC, this angle. Capital B is the size of angle ABC, this angle. And capital C is the size of angle ACB. So according to the law of sines, A over sine A equals to B over sine B, and it is equal also to C over sine C. We will implement the law of sines in triangle ABD. So this triangle ABD, according to the law of sines, we get that A over sine theta equals to 2 over sinus 60 degrees. In the next step, we will implement the law of sines in triangle ADC. According to the law of sines, we get that 2A over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. And we have the trigonometric identity that states that sinus 180 degrees minus theta equals to sinus theta. Sinus 180 degrees minus theta equals to sinus theta. That is to say, we can substitute sinus 180 degrees minus theta in this equation, equation number 2, by sinus theta. We'll do it now, and we get that according to equation number 2, 2a over sinus theta equals to dc over sinus 60 degrees. So here we have 2 times a over sinus theta, but a over sinus theta according to equation number 1 equals to 2 over sinus 60 degrees, so we can substitute a over sinus theta from equation number 2 by 2 over sinus 60 degrees. We'll do it now, and we get that 2 times 2 over sinus 60 degrees equals to dc over sinus 60 degrees. So here we have sinus 60 degrees on both sides of the equation, so sinus 60 degrees will get cancelled. So what is left from equation number 2 after we cancelled sinus 60 degrees? What is left is actually here, according to equation number 2, two times 2 equals to dc. So dc equals to 2 times 2, that is 4. So we can write here that dc equals to 4 units, exactly as we have already found out in the first method. In the next step, I present to you the law of cosines, and we'll implement the law of cosines in this triangle, triangle ABC. So I already mentioned it in the past, so we'll do it quickly. The law of cosines. So if we have triangle ABC, that could be any triangle. This is triangle ABC. Angle B is equals to theta. Side AB equals to A units in its length. Side AC equals to B units in its length. And side BC equals to C units in its length. So according to the law of cosines, we get that cosine theta equals to A squared plus B squared minus C squared over 2 times AB. I'll repeat again. We have a triangle ABC that could be any triangle. Side AB equals to A units, side AC equals to B units, and side BC equals to C units. And the angle between side AB and side AC is theta. Then according to the law of cosines, we get that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So actually, we'll implement the law of cosines in triangle ABC. So I copy triangle ABC in the new page, and we'll implement the law of cosines in triangle ABC. Okay. Angle BAC equals to 60 degrees plus 60 degrees, that is 120 degrees. Side AB equals to A units according to what is given us in the question. Side AC equals to 2A units according to what is given us in the question. Side BC equals to 2 plus 4, that is 6. So this is triangle ABC that they copied from the original drawing. We'll implement the law of cosines in this triangle, triangle ABC. So actually, according to the law of cosines, we get that cosine 120 degrees equals to AB squared, that is A squared, AB equals to A, so it is A squared plus AC squared. AC equals to 2A, so AC squared is 2A squared, it is 4A squared, minus BC squared. BC equals to 6, so BC squared is 36, so it is minus 36 over 2 times AB is A times AC is 2A. Okay, so question number 3 is the implementation of the law of cosines in triangle ABC. Cosine 120 degrees equals to A squared plus 4A squared minus 46 over 2A times 2A. Here cosine 120 degrees is minus 1/2. It is equal to A squared plus 4A squared is 5A squared minus 36 over 2A times 2A. Here in question number 3 we have 2 on both sides of the equation, so 2 will get cancelled. We'll multiply equation number 3 by 2A squared, and we get that 2A squared minus 1 is minus 2A squared. That is equal to 5A squared minus 36. Here we will add 2A squared and also 36 simultaneously to this equation number 3. And we get that according to equation number 3, 5A squared plus 2A squared is 7A squared. That is equal to 36. Here we will divide this equation number 3 by 7. And we get that according to equation number 3, A squared equals to 36 over 7. Here we take out of this equation number 3, and we get that A, according to equation number 3, A equals to the square root of 36, that is 6, over square root of 7. Okay, we found out the value of A equals to 6 over square root of 7 units. In the next step, I will present to you a new formula to find out the area of any triangle. So, if we have a triangle ABC that could be any triangle, this is triangle ABC. Angle BAC equals to theta. The length of side AB is equal to A units. The length of side AC equals to B units. Then, according to the new formula, the area of this triangle ABC, the area of triangle ABC will be equal to A times B times sinus theta over 2. I'll repeat again, the area of this triangle ABC that could be any triangle will be equal to A times B times sinus theta over 2. So here we'll implement the new we'll use the new formula in order to find out the areas of the triangles in our drawing. From the drawing, it is very easy to see that the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC again. Triangle ABC consists of two triangles, and the area of triangle ABC will be equal to the area of triangle ABD plus the area of triangle ADC. So write it down that the area of triangle ABC, the big triangle ABC, equals to the area of triangle ABD, this triangle, plus the area of triangle ADC, this triangle. Repeat again, the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. So, what is the area of triangle ABC according to the new formula? The area of triangle ABC will be equal to A times 2A times sinus 60 degrees plus 60 degrees is 120 degrees times sinus 120 degrees over 2. I repeat again, the area of triangle ABC according to the new formula will be equal to A times 2A times sinus 120 degrees over 2. And what is the area of triangle ABD according to the new formula? The area of triangle ABD equals to A times X times sinus 60 degrees over 2. I repeat again, the area of triangle ABD, this triangle, equals to A times X times sinus 60 degrees over 2. And what is the area of triangle ADC, this triangle? According to the new formula, the area of triangle ADC equals to X times 2A times sinus 60 degrees over 2. I repeat again, the area of triangle ADC equals to X times 2A times sinus 60 degrees over 2. So here we have 2 on both sides of the equation, so 2 will get cancelled. We have A on both sides of the equation, so A will also get cancelled. And we know that sinus 180 degrees equals to sinus 60 degrees. So sinus 60 degrees will also get cancelled. So what is left from this equation after we cancel all the variables? What is left is that in this side we have 2A. In the other side of the equation we have left with X plus 2X. Okay, X plus 2X. So in conclusion, I found out that 2A equals to X plus 2X, that is 3X. Here we divide this equation by 3 and we get that X equals to 2 over 3 times A. But we already found out that A equals to 6 over square root of 7 units, so we substitute A by 6 over square root of 7 units. So here we have 6 over 3 is 2, so it is 2 times 2 over square root of 7 units. 2 times 2 is 4 over square root of 7 units. So in conclusion, I found out that X, the line segment that we are looking for, it is equal to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay, so we finished with the second method. In the next step, I will summarize the lecture. We'll start with the first question. in the drawing, we have square ABCD. We know that side, the short line segment D equals to 1 unit. Inside the square we have this circle. We know that the radius of this circle equals to 2 units. And we want to find out the side length of square ABCD. So first of all, we define the side length as x. So here this equals to x, BC also equals to x, AB equals to x, and AD also equals to x according to our definition. Okay? And then I presented to you rule number 1 that I've already mentioned in the past. A tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have the radius OM of this circle. We defined actually the radius of this circle as r, so the radius OM that is equal to r, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AD with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent AD will be perpendicular to the radius MO. So if AD is perpendicular to MO, it means that this angle equals to 90 degrees and this angle will also equal to 90 degrees. In the next step, we join points O and M together by a straight line. ON is the radius of this circle. Why? Because point O starts from the center of the circle. Point M is a point on the circle itself. This is exactly the definition of a radius. So ON is the radius of this circle that is equal to R, that is equal to 2 units. R equals to 2 units. So we have here the radius ON, it is drawn to the point of tendency. And whenever you have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius LO. So if AB is perpendicular to LO, it means that this angle equals to 90 degrees and this angle will be also equal to 90 degrees. Okay, and we know that all the angles inside a square are right angles. Therefore, angle DAB equals to 90 degrees in square ABCD. So actually in quadrilateral OMAL we have 1, 2, 3 right angles. Here in quadrilateral MOAL we have 3 right angles. The sum of 3 right angles is 90 degrees times 3 is 270 degrees, plus the size of the fourth angle that is actually this angle MON. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 270 degrees from this equation and we found out that 360 degrees plus 270 degrees, it is equal to 90 degrees. So we found out that the missing angle here, angle MON, it is equal to 90 degrees. Actually we found out that all the angles inside quadrilateral MOAL are right angles. Okay, any quadrilateral that has 4 right angles must be at least a left angle. So we will relate to quadrilateral MOAL that has 4 right angles as a left angle. Okay? And we know that the opposite sides of a left angle are equal to each other. So in left angle MOAL, its opposite sides are equal to each other. That is to say MO equals to AN. MO equals to AN. But we have already found out that MO equals to 2 units. This is the radius of the circle. And from this equation 2 equals to MO equals to AN, we derive that AN is also equals to 2 units. AN is also equals to 2 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we get that MA equals to OL. Here is actually MA equals to OL, MA equals to AL, MA equals to AL, MA equals to AL, MA equals to OL, actually, MA equals to OL. According to the rule that the opposite sides of a rectangle are equal to each other, we get that MA equals to OL, but OL equals to 2 units. This is the radius of the circle. So here OL equals to 2 units. So, and from this equation MA equals to OL equals to 2, we derive that MA is also equals to 2 units. Here MA is also equals to 2 units, so actually we found out that all the sides of quadrilateral MOAL are equal to each other. Therefore, quadrilateral MOAL, it is not a rectangle but a square. Quadrilateral MOAL is a square. Okay? Then I presented to you rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. I repeat again, the lengths of two tangents from a common external point to a circle are equal. So we focus on the common external point, point E. From the common external point, point E, we have two tangents to the circle. The first tangent is tangent EM and the second tangent is tangent EZ. And according to rule number 2, the lengths of those two tangents, they are equal to each other. So actually here, EM equals to EZ according to rule number 2. Okay? What is the length of tangent EM? From the drawing, it is very easy to see that the length of tangent EM, it is equal to DA minus DE minus MA. Again, EM equals to DA minus DE minus MA. Here, EM equals to DA minus DE minus MA. So EM equals to DA. DA equals to X according to our definition. D equals to 1 unit according to what is given us in the question. And we have already found out that MA equals to 2 units. So in conclusion, we found out that EM equals to X minus 1 minus 2. X minus 1 minus 2 is X minus 3. So we found out that that EM equals to X minus 3 units. And according to rule number 2, EM equals to EZ. And we just right now found out that EM is also equals to X minus 3. So from this equation, X minus 3 equals to EM equals to EZ, we will derive that EZ is also equals to X minus 3. EZ is also equals to X minus 3. Okay, then we focus on the common external point, point B. This point B is the common external point here. From the common external point, point B, we have two tangents to this circle. The first tangent is tangent BN and the second tangent is tangent BZ. And according to rule number 2, the lengths of those two tangents are equal to each other. So here, in the common external point, point B, now that BN equals to BZ according to rule number 2. What is the length of BN? It is very easy to see from the drawing that BL equals to BA minus AL. Again, BA minus LA equals to LB. Okay? BN equals to BA minus LA. So BA equals to x, according to our definition. And a equals to 2, according to what we have already found out. So in conclusion, we found out that bn equals to x minus 2 from one side, but from the other side, according to rule number 2, bn equals to bz. So from this equation, x minus 2 equals to bn equals to bz, we derive that bz is also equals to x minus 2. Here, bz is also equals to x minus 2. Okay. Then we found out the length of line segment EA. What is the length of line segment EA? It is very easy to see from the drawing that EA equals to DA minus DE. Again, EA equals to DA minus DE. Okay. EA equals to DA minus DE. DA equals to x according to our definitions. D equals to 1 according to what is given as the question. So in conclusion, I found out that E equals to x minus 1. Okay? Then I copied the right triangle EAB in a new page, this page, and implemented the Pythagoras theorem on this triangle, triangle EAB. This is the right triangle EAB, this is a copy from the original drawing. EA equals to x minus 1. We just found out that E equals to x minus 1. AB equals to x according to our definition. And the hypotenuse EB equals to x minus 3 plus x minus 2. EB equals to x minus 3 plus x minus 2. X minus 3 plus x minus 2 equals to x plus x is 2x. And minus 3 plus minus 2 is minus 5. So in conclusion, we found out that the hypotenuse EB equals to 2x minus 5. So we implemented the Pythagoras theorem on the right triangle EAB, this right triangle. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So EB equals to 2x minus 5. So the hypotenuse is EB. Therefore, the square of the hypotenuse is EB squared. And it is equal to the sum of the squares of the perpendiculars. That is to say, it is equal to EA squared plus AB squared. So in conclusion, according to the Pythagoras theorem, we get that EB squared equals to EA squared plus AB squared. EB equals to 2x minus 5, so EB squared is 2x minus 5 squared. That is equal to EA squared. EA equals to x minus 1, so EA squared is x minus 1 squared. Plus AB squared. AB equals to x, so AB squared will be equal to x squared. We open the brackets on both sides of this equation, equation number 1. And we found out that 2x minus 5 equals to 2x minus 5 squared equals to 2x squared, that is 4x squared, plus 5 squared, that is 25, minus 2 times 2x is minus 4x, is minus 4x times 5 is minus 20x. That is equal to x minus 1 squared, x minus 1 squared equals to x squared, plus 1 squared, that is 1, minus 2x plus x squared. So in this side of the equation we have 4x squared minus 20x plus 25. In the other side of the equation we have x squared plus x squared is 2x squared minus 2x plus 1. Okay, here first of all we subtracted 2x squared from this equation, equation number 1. Four x squared minus 2x squared is 2x squared. Then we also added 2x to this equation, equation number 1. 2x minus 2x is 0. Minus 20x plus 2x is minus 18x. So here we have minus 18x. And we subtracted 1 from this equation. So here 1 minus 1 is 0. 25 minus 1 is 24. So in conclusion, we found out that 2x squared minus 18x plus 24 equals to 0. We divided this equation, equation number 1 by 2, and found out that 2x squared over 2 is x squared, minus 18x over 2 is 9x, and 24 over 2 is 12. So in conclusion, we found out that x squared minus 9x plus 12 equals to 0. This is a quadratic equation. the coefficient A equals to 1, the coefficient B equals to minus 9, and the coefficient C equals to C. The general formula for solving out a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So we put the data inside the formula and we find out the value of the values of x. So here x equals to minus b, b equals to minus 9, so minus b is minus 9, that is 9, plus minus square root of b squared. B equals to minus 9, so b squared is minus 9 squared, that is 81, minus 4 times a is 1, times c is 12, divided by 2a. A is 1, so 2 times 1 is 2. So we have here x equals to 9 plus minus square root of 81, minus 4 times 12 is minus 48, over 2. So here we have x equals to 9 plus minus square root of 81 minus 48 is 33. So inside the root we left only with 33 over 2. So here we will have two solutions that are possible for x. The first solution for x is x equals to 9 minus square root of 33 over 2. 9 minus square root of 33 over 2 is 1.62. So we found out that x equals to 1.62. Here, this is x, and here, according to the first solution for x, it is equal to 1.62 units. But because of the fact that x is longer than AL, x is longer than AL, and AL itself equals to 2 units, and x is longer than AL. That is to say, x must be greater than 2 units. Okay, x must be greater than 2 units. From the law, it is obvious that x must be greater than 2 units, but according to the first solution, x that is equal to 1.62, it is less than 2 units. Therefore, this solution is incorrect solution. We cancel the solution and we left only with the second solution, that x equals to 9 plus square root of 33 over 2 units, or in terms of numbers, it is equal to 7.37 units. So I found out that the side length of this square ABCD is equal to either 9 plus square root of 33 over 2 units, or in terms of numbers, it is equal to 7.37 units. We finished with the first question. Then I presented to you the second question. The first method to solve the second question. In the second question, we have triangle ABC. We know that BD equals to 2 units, AB equals to 8 units, AC equals to 2 units, angle BAD equals to 60 degrees, angle DC equals to 60 degrees, and we want to find out the length of side AD that is equal to x. So first of all, I presented to you the angle bisector theorem. The angle bisector theorem is for any triangle. So if we have this triangle ABC, that could be any triangle, and we have line segment AD, that is actually the angle bisector. Why segment AD is the angle bisector? Because of the fact that it divides angle BAC into 2 halves. Each half equals to theta. So if you have triangle ABC, that could be any triangle, and we have the angle bisector in triangle ABC, then we can then the following equation is true, that AB over AC equals to BD over DC. Again, AB over AC equals to BD over DC. We implemented the angle bisector theorem in triangle ABC. Why we can implement the angle bisector theorem in triangle ABC? Because because AD is the angle bisector. Here AD divides angle BAC into 2 halves. Each half equals to 60 degrees. Therefore, we can implement the angle bisector theorem in triangle ABC. So according to angle bisector theorem, we get that AB over AC equals to BD over DC. AB over AC equals to BD over DC. AB equals to A, AC equals to 2A, BD equals to 2, and DC is the missing line segment. We found out that A over 2A equals to 2 over DC. A over A is 1, so A will get cancelled, and the left only with 1 half equals to 2 over DC, because multiply this equation, equation number 1, and we found out that DC equals to 2 times 2. So 2 times 2 is 4, so DC equals to 4 units. We found out that the missing line segment DC equals to 4 units. Then we did a construction. We extended side CA by a straight line, and from point B we raised perpendicular to the extended CA. Okay, so this angle equals to 90 degrees according to our construction. Angle AEB equals to 90 degrees according to our construction. So we define then the touching point of the extended CA and the perpendicular from B is E. Okay. Then we focused on the right green triangle, triangle EAB. In this green right triangle, actually here, before that, we did the construction by extending side CA of triangle ABC by a straight line, and this way we got line segment CE. CA is the side of a triangle, it is a straight line, and when we extended the straight line CA by a straight line, we got line segment CE. And when you extend the straight line by a straight line, the result must be a straight line. So here, EC is a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the lower side of the straight line EC at point A, then the sum of the angles here must be equal to 180 degrees. So which angles we have here? At the lower side of EC at point A, we have here 60 degrees, plus 60 degrees, plus angle EAB. In total, the sum of those three angles must be equal to 180 degrees. I'll repeat again. 60 degrees plus 60 degrees, plus the size of angle EAB. In total, they must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line must be equal to 180 degrees. 60 degrees plus 60 degrees is 120 degrees, so according to this equation, we found out that 120 degrees plus angle EAB equals to 180 degrees. Here we subtracted 120 degrees from this equation and found out that the missing angle EAB equals to 180 degrees minus 120 degrees, it is 60 degrees. So this angle, the missing angle here is 60 degrees. Then we focused on the green right triangle, triangle EAB. On the green right triangle, triangle EAB, we know that cosine 60 degrees equals to EA over BA. And cosine 60 degrees equals to EA over BA. So cosine 60 degrees equals to EA over BA, but BA equals to A, according to what is given us in the question. So we can substitute BA by A. So in conclusion, we found out that cosine 60 degrees equals to EA over A. And cosine 60 degrees equals to 1 half, so we substitute cosine 60 degrees equal to 1 by 1 half. And we got that 1 half equals to EA over A. We multiplied this equation by A and found out that EA equals to A over 2. Here, the left of side EA equals to A over 2. Then we continue to focus on the right green triangle, triangle EAB. On the right green triangle, triangle EAB, we know that sinus 60 degrees equals to EB over BA. Sin of 60 degrees equals to EB over BA. So sin of 60 degrees equals to EB over BA, but BA equals to A, so we substitute BE by A. And we know that sin of 60 degrees is square root of 3 over 2, so we substitute sin of 60 degrees by square root of 3 over 2, and we found out in conclusion the square root of 3 over 2 equals to BE over A. We multiply this equation by A, and we found out that B equals to square root of 3 over 2 times A. Okay, we found out here that B equals to A times square root of 3 over 2. Then we implemented the Pythagoras theorem in the right triangle, the right big triangle, triangle BEC. So I copied the right triangle BEC in a new page, in this page, and we implemented the Pythagoras theorem on this right triangle, triangle BEC. What is the length of side EC? The length of side EC from the drawing is very easy to see that it is equal to 2A plus A over 2. 2A plus A over 2 is 2.5A. And 2.5A is 5 over 2A. Okay? And EB equals to square root of 3 over 2 times A. And the hypotenuse BC equals to 2 plus 4, that is 6. Okay? So we implemented the Pythagoras theorem on the right triangle, triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BC square equals to BE square plus EC square. BC equals to 6, so BC square is 6 square, that is 36. And it is equal to BE square. B equals to square root of 3 over 2 times A. So B square is square root of 3 over 2 times A square plus EC square. EC equals to 5 over 2 times A, so EC square is 5 over 2 times A square. Then we open the brackets here, and we got that 36 equals to 3 quarters A square plus 25 quarters A square. 3 quarters plus 25 quarters is 28 quarters. And 28 over 4 is 7, so 36 equals to 7A squared. We divided this equation by 7, we got that A squared equals to 36 over 7. We took out of this equation number 2, and we found out that A equals to 6 over square root of 7 units. Then I presented to new rule to find out the and then I presented to you rule number 3. According to rule number 3, if we have triangle ABC, that could be any triangle, and in triangle ABC we have the angle sector AD, then AD square equals to AB times AC minus BD times DC. Okay, we implemented the angle sector theorem in triangle ABC, so I copied triangle ABC in this new page, and we implemented rule number 3 in triangle ABC. According to rule number 3, we get that AD square equals to AB times AC minus BD times DC. AB equals to X, so AD equals to X, so AD square is X square. That is equal to AB is 2, AC is 2A, DB is 2, and DC is 4. So X square equals to A times 2A minus 2 times 4. So X square equals to A times 2A is 2A square, minus 2 times 4 is minus 8. So X square equals to 2A square minus 8. Here, X square equals to 2A square. A square equals to 36 over 7. So we substituted A square by 36 over 7 and found out that X square equals to 2 times 36 over 7 minus 8. 2 times 36 is 72. And we multiplied 8 by 7, we multiplied minus 8 by 7, and then we divided by 7 in order to overcome a factor with this expression. And we found out that X square equals to 72, and minus 8 times 7 is minus 56 over 7. 72 minus 56 is 16. So in conclusion, we found out that X square equals to 16 over 7. We took out of this equation and found out that X equals to 4 over square root of 7 units, or in terms of numbers, it is 1.51 units. Then I presented to you the second method to find out the length of side AD that is equal to x. Here we defined angle ADB as theta, therefore angle ADC must be equal to 180 degrees minus theta. And I presented to you the law of cosines. The law of cosines is drawing an triangle. Here A over sine A equals to B over sine B equals to C over sine C. We implemented the law of cosines in triangle, the law of sines in triangle ABD. According to the law of sines in triangle ABD, we will get that A over sinus theta equals to 2 over sinus 60 degrees. Then we implemented the law of sines in this triangle, triangle ADC. According to the law of sines, we will get that 2A over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. And we have the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta. So we can substitute sinus theta, sinus 180 degrees minus theta by sinus theta. We did it, and we got that according to equation number 2, 2A over sinus theta equals to DC over sinus 60 degrees. And here we have 2 times A over sinus theta. But A over sinus theta equals to 2 over sinus 60 degrees according to equation number 2. So we substituted A over sinus theta in equation number 2 by 2 over sinus 60 degrees from equation number 1. And we got that 2 times 2 over sinus 60 degrees equals to DC over sinus 60 degrees. We have sinus 60 degrees on both sides of the equation, so sinus 60 degrees will get cancelled. And found out finally that DC equals to 2 times 2. DC equals to 2 times 2, that is to say DC equals to 4. Found out here that DC equals to 4 units. That implemented the law of cosines in triangle ABC. According to the law of cosines, we get that cosine theta equals to A squared plus B squared minus C squared over 2 times AB. We implemented the law of cosines in triangle ABC. According to the law of cosines, we get that cosine 180 degrees equals to A squared plus 2A squared, that is 4A squared, minus 6 squared, that is 36. Over 2 times A times 2A. Cosine 120 degrees equals to minus 1/2. So here we have A squared plus 4A squared is 5A squared minus 36. We have 2 on both sides of the equation, so 2 will get cancelled. And we got that minus 2A squared equals to 5A squared minus 36. We added 2A squared and also 36 simultaneously to this equation and found out that 7A squared equals to 36. We divided the equation number 3 by 7 and found out that A squared equals to 36 over 7. We took out of this equation, equation number 3, and found that x equals to 6 over square root of 7 units. Then I presented to you a new formula to find out the area of any triangle. The area of this triangle, triangle ABC will be equal to A times B times sinus theta over 2. Then, in our trouble, we know that the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. So here, we found out that the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. The area of triangle ABC, according to the formula, will be equal to A times 2A times sinus 120 degrees over 2. A times 2A times sinus 120 degrees over 2. The area of triangle ABD, according to the formula, will be equal to A times X times sinus 60 degrees over 2. A times X times sinus 60 degrees over 2. And the area of triangle ADC equals to, according to the formula, equals to x times 2a times sinus 60 degrees over 2. A times 2a, x times 2a times sinus 60 degrees over 2. We have 2 on both sides of the equation, so 2 will get cancelled. Sinus 120 degrees equals to sinus 60 degrees, so, and we have sinus 60 degrees on both sides of the equation, so sinus 60 degrees will also get cancelled. And we have A on both sides of the equation, so A will also get cancelled. Okay? And finally we found out that 2A equals to x plus 2A. That is to say 2A equals to x plus 2x is 3x, so 2A equals to 3x. We divided this equation by 3 and found out that x equals to 2 First A, and A equals to 6 over square root of 7 units, so we substituted A equals to 6 to 6 over square root of 7 units, so we substituted A by 6 over square root of 2 units, and found out that x equals to 2 times x equals to 2 over 3 times 6 over square root of 7 units. Here 6 over 2 is 2, so x equals to 2 times 2 over square root of 7 units. That is to say x equals to 2 times 2 is 4, so x equals to either 4 over square root of 7 units, so in terms of numbers it is equal to 1.5 units. It is equal to 1.51 units, exactly as we found in the first method. Okay, thank you very much.